Okay, we are live. All right, so we're starting on 7.3 here today. Now, yesterday we talked about similar shapes, and we talked about how you had to know all the proportions of all the sides, and all the ratios, and they all had to be the same to prove that those sides were proportional, to prove that the shapes were similar. Well, with triangles, we don't have to know all of it. We can. And if you know that all three sets of sides are proportional, meaning that all the ratios come out to be the same, then you know that those shapes are similar. And that's called side triangle similarity. Okay? But you don't have to know that. One thing that you could know is if you know two of the angles are the same in those two triangles, you know the third one has to be the same because of that third triangle congruence theorem, right? Or third angle theorem. So if you know two angles in the two triangles are the same, you know those triangles are similar. If you know one angle is the same in the two triangles, and then you know that the two sides that make that angle are proportional, so you know that the triangle or the angles are congruent, and the two sides are proportional, then that tells you that those triangles are also similar. Okay? So these three things are three different ways that you can prove two triangles are similar. All right? So now, if we go to our sheet, right? Look at number 1. So on number 1, it shows that this angle is congruent to this angle. So we know that we have one angle congruent to one angle. Then, notice they didn't give us any numbers on this, but they did tell us that this and this are the same, and this are the same. That means if we set up a ratio of this side to this side, and a ratio of this side to this side, they're going to be the same because those numbers are the same. So if those ratios are the same, that means it's proportional. So we know, based on this, that a side, this side to this side, is proportional. An angle is proportional, and then a side is proportional. Side, angle, side. Y'all see how that works? Does that make sense to everybody? So based on that information, we know these two triangles are similar. And if we were going to write a triangle similarity statement, we would say triangle, like TSR, is similar to triangle, and then we match up the angles. So if we're doing T, we would do W, then S would go with S, and then X would go with R, right? Y'all with me? Okay, if we look at number 2, what information did they give you there? What information do you have on number 2? Yeah, of what? Just sides, right? We don't have any angles here. That tells us right off the bat that if we're going to prove these two triangles are similar, we will have to use side, side, side. That means we'll have to set up ratios for each set of sides to see if those ratios are the same. If they are the same, then they are similar. But we have to check each side because that's all we have is side information. How do you know which side compares to which side when we don't have any angles? How do you know which one to compare? Right. So you base it on what's the shortest side in this triangle and what's the shortest side in that triangle. What's the next shortest? What's the next shortest, right? So the shortest in this triangle is 8 and the shortest in this triangle is 6, right? So we compare 8 to 6 and make a ratio out of that. Now, if we simplify that, what goes into both 8 and into 6? 2. So 2 goes into 8 4 times, 2 goes into 6 3 times, so that simplifies to 4 over 3, right? Then we're going to compare the other side. So we take the next side's here, which, by the way, since these are the same numbers, we only have to do this one time. There's no point in doing it 2 times. We're going to get the same answer, right? So we have 12 and we have 9, right? But we're going to simplify it and see if it simplifies to be 4 over 3. What goes into 12 and what goes into 9? 3. How many times does it go into 12? How many times does it go into 9? So did we get the same thing? And then, of course, if we did that other 12 and 9, we're also going to get 4 over 3. So because our 3 sides, our 3 sets of sides are proportional, then these 2 triangles are similar based on side, side, side similarity, right? Now, when you do the practice side on the interactive worksheet, what you're going to be doing is it's going to say like yes, and it's going to say like no, right? And you're going to select yes, they're similar, no, they're not. And then there's going to be a box that has side, 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 angle, side, and then angle, angle. And then it's going to have like NA. If you say yes, you have to pick one of these 3. Which one did you use? Okay. If you say no, you're going to say NA. Does anybody know what NA stands for? Close. It's not applicable. Excuse me. Oh my gosh. Applicable means it doesn't apply. Not applicable means it doesn't apply to this. Okay? Okay, look at number 3. Based on the information we have here, which theorem might we be using? Side, angle, side. We know the angles are congruent, right? We know that angle S is congruent to angle J. We know that because it says they're both 70, right? So then we're going to fix up our proportions for the side. So we're going to go the short side on this one to the short side on that one. So 10 over 15, right? Then we'll do the long side on this one to the long side on that one, 14 over 21. Right? And now we just simplify and see if we get the same numbers. What goes into 10 that also goes into 15? 5. How many times on top? How many times on bottom? Okay, what about this one? What goes into 14 that also goes into 21? 7. How many times on top? How many times on bottom? So, did we get the same thing? Yes. So, are these triangles similar? Yes. What theorem did we use to prove it? SAS. Side, angle, side. So, everybody see how that works? Okay. Look at number 4. What information did they give you? They gave you 2 angles. So, we're going to be using angle, angle. And I know some of you right now are saying, oh, well, they're not because that one's 60 and that one's 30. But if this one's 60, what's that one? It has to be 30 because 180 minus 90 leaves 90. 90 minus 60 is 30. Are these 2 triangles similar? Yes. Based on what? Angle, angle. Right? Because we have 2 90-degree angles, so angle S is congruent to angle R, right? And then angle Q is congruent to angle M. And we know that the third angle has to be congruent if you have 2 congruent angles, right? Okay, y'all see how simple this is? Like, it's pretty simple, right? Okay, now, down here we're going to have to solve some stuff. I need to sharpen my pencil real quick, though. Hang on. My pencil's got down. You know where the wood is touching the paper when you're trying to write? I don't like pencils that sharpen with one side the wood stays on there. That drives me crazy. Yeah, you're hitting the wood already. Okay, so on this, notice we have this angle's congruent to this angle right here, right? So we know that those angles are congruent. And then this angle here is congruent to this angle, which tells us these two triangles are similar, which, by the way, all of these are going to be similar because we know they're going to be because we're solving it, right? But it doesn't hurt for us to go ahead and look at which angles and which sides. Since this angle is congruent to this angle and this angle is congruent to this angle, then that means this is the sides that are going together, 15 and 12, right? It doesn't matter which one we put on top and which one we put on bottom. Doesn't make any difference. But whichever one you put on top, on one side, you go from the same triangle on the other side, right? So if we do 15 over 12, like so, right? Then on the other side, we have to go from the same triangle that 15 came out of. So what goes on top over here? X plus 5. And what goes on bottom? X plus 1. Now, we can cross multiply right here, or we can simplify 15 over 12 first and make our math easier. Simplifying will make your numbers smaller, and you may not need that calculator you're hanging on to. Okay? What goes into 15 that also goes into 12? How many times in 15? How many times into 12? Okay? So that makes our numbers smaller, and we don't have such big numbers to multiply. So we're going to do 4 times x plus 5. So it's going to be 4x plus 20, because we do 4 times 5, right? And then we're going to do 5 times x plus 1. So 5 times x is 5x. 5 times 1 is 5, right? So now we have just a basic little equation to solve. What would you move? What would you move? Subtract 4x. Okay.
And then subtract 5.
And then subtract this 5. So what that does is it gets rid of the x's on this side and it gets rid of the numbers on that side, right? And we have x on this side, 15 on that side. Is that my answer? No, it's not, is it? Why is it not the answer? Yeah, they're asking for what AC is. So now we've got to go back to the problem and be like, all right, so AC is x plus 1. X was 15. So what's my answer? 16. So my answer is 16, not 15. Make sure you're answering what's actually asked, okay? Okay, so we look at this one. Notice how we've got these parallel lines here? Well, these parallel lines, we know if that's a transversal, then this angle is going to be congruent to this angle, right? We know that these are vertical angles, so they're going to be congruent. So we know the triangles are congruent based on angle, right? We also know that this angle here is going to be congruent to this angle here because of that transversal thing. Now, they only gave us some very basic information. We know we're going to line up the 14 and the 16. And it doesn't matter which way we go. Do y'all want 16 on top or 16 on bottom? Top? So we're going to do 16 over 4, right? That means on this other side, what has to go on top? The x plus 18, right? You have to put the one that's from the same triangle over there. If you don't set it up to where you're doing, this is big triangle, little triangle, over here has to be big triangle, little triangle also. If you don't, you're messing up. What's going to go on bottom? X minus 3. Now, let's go ahead and simplify this to make our numbers smaller. So what goes into 16 and into 4? 4. How many times does 4 go into 16? How many times does 4 go into 4? So that gets us down to 4 over 1, right? Okay, so then we're going to multiply 1 times x plus 18. That's going to be x plus 18. And then 4 times x minus 3. So 4 times x is 4x. 4 times negative 3 is negative 12. Does everybody see where we're at? Anybody got a question so far? Okay, what would you do to solve? Subtract x. Okay, that gets rid of my x's. What else can I do? Oh, I got to do that. Yep. Sorry. Thank you, Jonathan. I also can, right now, add 12. That gets rid of my 12s, but then I have to do it over here too, right? So that gets me 3x equals 30. So divide by 3, what is x? 10. Is that my answer? No. What's my answer? 28. So my answer is 28. No units, because they didn't give us any units in this problem. Okay, so far so good? All right, let's look at number 7. Okay, do y'all see 2 triangles in number 7? Does everybody see 2? So there's this little one, just in case. There's this little triangle, and then the big triangle, right? And we know we're going to be comparing 6 and 12, because that's the bases of both triangles, right? So do y'all want to put 12 on top or 6 on top? 6. So we're going to do 6 over 12. And that's going to equal, so we have, this time we're doing little over big. See how it doesn't matter which one we do? We just got to keep it consistent. So over here, what's going to go on top? X plus 5. And then what's going to go on bottom? It is not 9. Yeah, so here's the deal. They didn't tell us what this side was. They told us this piece. They told us this piece. We have to add those together. So we have to add x plus 5 plus 9 to get this long side, which is going to be x plus 14. Y'all see? So you got to pay attention to little things like that, or you'll set it up all right, but then get the wrong answer because you didn't pay attention to the fact that that wasn't the whole side. Now, can we simplify the 6 and 12? What goes into both? How many times into 6? How many times into 12? So 1 over 2, right? So that's going to get us 1 times x plus 14, x plus 14. 2 times x plus 5. So that's going to be 2x plus 10, right? What would you move? Move that x? What else would you move? So that gets rid of my x's over here, and it gets rid of my 10's over there, right? 14 minus 10. 2x minus x. So x is 4. What are they asking for? They're asking for EH. We don't know EH.
It's x plus 5.
How do you know that?
Because the x plus 5 and the 9.
Yep, because it's the same, right? Because it's the same. So 4 plus 5 gives me 9. So this is 9 and that's 9. Okay, got one more we're going to do. We've got this one. So what do y'all want to put on top? 14 on top? That means we're doing big on top, little on bottom. So over here we have to do big on top, little on bottom, right? So what's going to go on bottom over here? X plus 2. What's going to go on top? You got to add them again. See how they didn't give us both of it, the whole thing this time? They just gave us the pieces, so we have to add them again. We have to do 3x minus 3 plus x plus 2. So that's going to be 4x. And then what's negative 3 and plus 2?
1.
Minus 1. Okay. So let's simplify that 14 over 6. How do we simplify that? What goes into both? 2 goes into both. So what would be on top? 7. What would be on bottom? 3. Okay. So now we're just going to cross multiply, right? So we're going to have 3 times 4x, which is 12x, and 3 times negative 3, which is negative 3. Yes, ma'am. Okay. Juliana? And then we're going to have 7 times x plus 2. So 7 times x is 7x. And 7 times 2 is 14. Right? Now what? They know she doesn't speak English. Did they have a translator? Okay. I didn't see a translator, so. Okay. So what are y'all moving?
7x.
Moving the 7x. Okay. And add the 3. So you wind up with 5x equals 17, right? So when you divide by 5, you know you're not getting a whole number. What's it going to be? 3.4. Is that my answer? No, because what did they ask for? VT. So what is my answer? 5.4. Because we do 3.4 plus 2. So it's going to be 5.4. Now I know some of you right now are thinking, oh, we messed up because we got a decimal. Y'all, answers can be decimals. That was very basic math. We didn't mess up anywhere. It just is a decimal. Okay? Sometimes answers can be decimals. And our textbook information, they're really bad to throw one decimal answer on the whole page. And that really makes you think you messed up. Because if you're getting decimals randomly, then you don't think that much about it. But if you just get one out of the whole page and everything else is a nice, pretty whole number, then you think, uh-oh, I did something wrong. Right? But you didn't. It really is 5.4. Okay, so your assignment is going to be the practice side. There is not an interactive worksheet yet. Actually, there is one, but I messed up on it and I have to fix it. You do not have to do number 7 today. We're going to mark that one off. So you're just going to be doing 1 through 6. And you're not going to put your interactive answers in until tomorrow because I've got to go back and fix that worksheet because I messed it up. Have you finished it? Did you take a picture of it and post it on Google Classroom? You got to do that. Once you've done that, I don't care what you do with it. But you have to take a picture of 7.2 and post it on Google Classroom. Okay? Kamina, we need you to join our Google Classroom. Do you have a Chromebook yet? Okay. Get your Chromebook out